I have the pleasure of welcoming Mr. Chris Wright. He serves as Chief Technology Officer and Senior Vice President for Global Engineering at Red Hat. He leads a team that guides Red Hat's vision for technology, including elements such as engineering, product security, customer experience, and technology incubation. And Chris is a software engineer by trade and has over 25 years experience, and he's very passionate about open source software as the foundation for next generation IT systems. So Chris, we're really looking forward to your keynote. Welcome to the program.
Thank you, Megan. And just thanks for having me today. What a privilege to be able to speak with you all on maybe some topics that are near and dear to my heart, and hopefully I can make them near and dear to your heart. That's part of my goal here. And I wanted to share what I'm hearing as I have the privilege to travel really globally and speak with a broad customer base. Talking about technology, certainly where Red Hat sees open source fitting into this picture of the evolution of technology. So just as a quick starting point, for those of you who don't know Red Hat, I wanted to share a couple of points about who we are, about the company. First, we are the world's #1 provider of open source commercial IT products and solutions. And that's something we are very proud of because we stand out in a space that historically was questioned. How real is this? And today it's really gone mainstream. So as a result, we are roughly 20,000 employees, and we're proud to say that 90% of the Fortune 500 use our products. And everything that we do starts in the open source communities and what we call upstream. Now, this approach is very unique in the software industry, and we live in these two worlds, the world of open source software development, sometimes I refer to it a bit as the Wild West, and then the world of business, where we apply software to help run businesses. And that straddling of those two worlds is really a core of the value that we bring to our customers. And living in these two worlds, I'm amazed at how much open source has evolved and impacted companies globally. Our strategic focus is on building out a hybrid cloud vision, which transitions from traditional on-premises data centers to a public cloud across multiple public clouds, and increasingly and excitingly out to the edge, helping customers really modernize and take advantage of cloud-native capabilities and building new applications that can fit either your business goals or your mission to get you there as quickly as possible. I'd also like to point out, relevant probably more to this audience, Red Hat is in all 16 cabinet-level agencies, and 50 states, across the US are using our products. So we understand not just the enterprise business, but also government needs, which I think is important when you look at things like compliance and certification, and certainly here talking about things like security. So as I said, I get to talk to customers all the time, and I wanted to share with you these themes that I hear very consistently. The first is maybe a little trite. All companies, all agencies are becoming software focused. You build your mission, you build your value out of software. You're technology focused. A little trite because there's a lot of details under there that I think really matter, but this is very consistent. We hear this focus on building technology or building software with technology as the underpinnings. And as a software company, we relate well to that. We deliver software, we do that all day long. And the way I like to think of it is, well, we're a software factory. So how can we help our customers become a software factory? Time to value, time to mission, these are really important things for our customers. And the tool set and the processes and cultural changes that go along with the tool set are critical to success. The other kind of trite or possibly buzzword-focused area is being data-driven. So you'll hear this all the time. I'll dig into it a little bit more. Again, easier said than done. There's a lot of work under the hood of what it means to become a data-driven business. So I think there's some interesting analogies between software development and data science that we can draw from and learn from across these two disciplines, and even look at ways that we can connect them together. Globally, customers are looking at managing risk and ensuring compliance. And risk here is largely focused around the supply chain and security risks. Nobody wants to be on the front page of a business journal, and looking at how you manage your risk profile in the context of moving quickly is a meaningful challenge. And then finally, we deal with large customers that have a global footprint. How can you be operationally resilient around the globe, leveraging different types of infrastructure, which I think is already showing itself in the form of the Operational Resilience Act, DORA, in the EU, requiring some ability to move applications from one cloud to another cloud in a short period of time. When you think about banking being part of the national economy, it becomes a really big concern. And when you think about edge computing, providing that resiliency highly distributed is a big challenge for customers. So I just wanted to dig into these a little bit more in detail. So first I'll focus on that sort of how do we build and deliver software. I think number one is accelerating the ability to quickly deliver software into production and doing that responsibly. So there's lots of tools out there, and especially in the open source world where technology moves quickly, how can you deliver those tools to your developers that are focused on a specific outcome without sacrificing your compliance, your risk profile, and think about delivering the value that's important to you as a business, or delivering on your mission. In there's a question around operational efficiency. Many of these customers that I work with have a long history of building software or consuming software in some way, shape, or form. I like to joke that the enterprise is basically an archaeological spelunking experience of finding all software that's ever been produced. So how do you modernize, and what do you modernize? When is it appropriate to actually modernize an application, or just leave it in place and slowly build around it? And certainly delivering applications to multiple clouds is a challenge. So in there, we take a view of building some commonality. You get developer efficiency by targeting a common platform. You get operational efficiency by targeting a common platform. We look at supporting our customers by building a common CI pipeline and delivering software independent of the underlying infrastructure, whether it's on premises, whether it's in a cloud, to that common platform using these common procedures so that different development teams can share best practices. And of course, from a security policy perspective, you can provide a common way of building policy declaration and then policy enforcement. Now, the struggle to be data-driven is interesting in the sense that many data science projects fail. A couple of different analysts and some experts in the space cite numbers around 80% of data science experiments failing. And then when you take that and connect it to all the data that we're producing, by 2025, we're expected to have 175 zettabytes of data. 70% of that data is dropping on the floor. So between failed experiments and not capturing all the data, there's a lot of improvement that we can manage in this space. I like to think about this as we've understood how to lifecycle manage applications. We know source code, we know building binary artifacts, we know testing and integration and delivering into production. That's a CI pipeline. We understand revision control. We know how to update and roll back and all of these things that we've learned over decades. Where is that discipline in data science? And how do we create an AI pipeline? How do we deliver the notion of data as source and a trained model as a binary artifact with a life cycle around it? And as you do, the effective configuration changes in application, parameter tweaking in data science, affecting the outcomes, predictability outcomes, predictive nature of the model, how do we capture that and know when we're making forward progress and need to, or regressing and need to back out and update our model? So we think of this as data is becoming a central actor. And our experience in building platforms that support application development, we want to make sure that we can support data science and the workloads that run associated with data science on our platform. And in the end, bring them together. As we see intelligent applications that take advantage of models, maybe even models surfaced with the REST API that can be directly integrated into applications as a key part of building value. And some of our partners in the defense space think of this very mission-focused on models having really a core part of the mission deployment in the inference engine. And speaking of inference, when you're doing scale-out model training and then delivery, deployment of a model to, say, even an edge device, we have to look at the underlying hardware. So as an operating system company and personally as a developer in the operating system space, I love the fact that hardware is evolving quickly, and hardware is evolving to meet the needs of applications and things like data and AI-based workloads. So bringing that together in a way that doesn't require data scientists to become experts in the underlying hardware or in the tool chain surrounding that, which is developed in open source communities and moving forward very rapidly, we can deliver a kind of a prescriptive AI pipeline-focused ML ops type of experience, targeting a common platform and bringing this world of application development and data science closer together. All right, so what about software supply chain security? An uncomfortable and staggering statistic is in the last year, there's been a 650% increase in year-to-year attacks on the software supply chain. That's concerning, and some of that happens directly in open source communities. I think an example like Log4j was a great wake-up call for the industry to question not is open source itself safe, but when you take software and put it into production, where did the software come from and where is it running in production? And how do you maintain that visibility? So we think of this in terms of a software supply chain. We have been working in open source communities to build new tools to manage the software supply chain and trying to create the shift left or DevSecOps tool chain to support software developers not needing to become security experts. I have a security background. I can tell you confidently, it's not realistic to expect the entire software development population to become security experts. We can infuse security expertise into a pipeline through recommendations in the developer's environment in an IDE, through to static analysis, through to dynamic fuzz testing, cryptographic signatures as you build artifacts and then validate those signatures as you deploy artifacts so that you kind of create this whole trust environment from the beginning of the software supply chain to delivery into production and manage visibility into where you're delivering software into production so you're not surprised when there's a vulnerability that we didn't know about and you don't actually know where that software is running. Looking at this from the perspective of the full stack, inclusive of hardware. So when you're delivering software and inference engines on the edge of your world, and the edge means different things to different people, edge is often exposed to the public. It's not within the four walls of a data center or in a public cloud. So we need to be able to understand the trust profile of the entire software stack, inclusive of hardware, as you boot up and deliver changes to these edge environments. So the types of tooling that we're focused on in communities and in our products is enabling that end-to-end solution around software supply chain and give software developers quick visibility into where they're pulling in known vulnerabilities or potentially producing code that has patterns that are known to be buggy. Finally, about operational resilience. The world is distributed, and when you really factor in something like edge computing, it cements the notion that hybrid is the reality. Hybrid meaning delivering application content to multiple different infrastructure footprints. We're building the capabilities to show the policy and the sort of the declarative language of policy that you want to manage those applications. And when you use a common infrastructure or a common platform underneath the applications, you can enforce that policy consistently, regardless of where it's deployed. To me, this is a critical part of flexibility and choice for our customer base as you're looking at how you deliver quickly and manage that operational efficiency, but also share best practices within teams that are responsible for different parts of the application portfolio to build resilience and resilient practices into your into the operations teams that are responsible for each of the applications. We actually build capabilities that are trying to create what I would call an autonomous system, or in my early days of research, we worked on a DARPA grant called Autonomics, which is building autonomic systems. There's a holy grail there that we won't fully realize, but building the tools that can do observation through telemetry and build execution plans to remediate issues that you see in your applications or in your infrastructure, that's where we're putting our investment, and we know over time we'll just continually improve the automation and increase the autonomy of systems. Finally, I'd just like to zero in on how we operate across industries. So I mentioned we're across the Fortune 500 and in many agencies. Here is an example of how we've worked with an ecosystem to fully transform an industry. This industry is a telecommunications industry. In fact, a lot of interest between the ecosystem and the US government on producing innovation in the 5G space from both a security perspective and a business perspective. Here, we help create a common technology base, whether it's Linux or Kubernetes, for the industry to focus on and enable the entire industry to move together through this collaborative model. And first, this was about introducing virtualization into networks and 4G and slowly moving to containerization and cloud-native principles in 5G. 5G becomes this connection point to the edge. And when we look at what we're doing in the edge space, you can see hardware gets more and more interesting. We have different types of architectures. We have new accelerators, IPUs and DPUs that can build these distributed systems that are low power, high performance, and ultimately look at that same disruptive model across different industries that can rally together around common technology building blocks to fundamentally move us forward. And to me, this is really exciting, and I see this happening most at the edge, where the edge use cases are very industry vertically focused. And I listed here a number of spaces where we're invested, including bringing functional safety into vehicles, relevant for both automobiles, but also UAVs, and a whole set of industry-focused areas on the edge that bring data as that central actor, data that we're collecting through all the telemetry, that's how we're observing the real world and then making real-time changes to behavior so that we can best deliver on the mission or realize greatest revenue growth for business use cases. So hopefully that just gives you a taste of what we're up to and where we see these interesting sort of conversations happening in our customer communities. And what I really love to do, if we have time, is hear from you where that resonates, where you see challenges, maybe even some experiences you have in tackling those challenges. And really thank you for the time today.
Great, thank you for that keynote, Chris. Really appreciate it. And happy to open it up to our in-person audience here if you have any questions. So feel free to raise a quick hand. But I'm going to get started with just a couple of questions we received from our virtual audience as well. Right. And you had talked about creating operationally resilient systems, and there were just additional questions about what are you hearing from your customers as some of the greatest challenges to build resilient systems upon hybrid or multi-cloud infrastructure? If there's just a couple of quick anecdotes you could share.
There's a few key challenges. Number one is there's a skills challenge across our customer base. So bringing the skills up to modern tools is a real challenge. Number two, you can only improve what you're measuring. So observability is a really important topic. Telemetry, understanding what's happening in systems is challenging. And in the end, we're building more and more complicated systems. So we need to be able to ensure we don't overly complicate things. You could talk about microservices, and if you break something down into 2 fine-grained small pieces and connect it all back together, you have a very complex system. So finding the right level of granularity it is really important to manage some of that complexity. And again, with that complexity that we're creating, we need to build automation tools around that. And so part of it is the observability, part of it is the skill set, part of it is sort of managing complexity. And where you can, if you look at what a hyperscaler does very effectively, why they operate at such scale with such efficiency, it's having these sort of large-scale, consistent building blocks. There's not a lot of heterogeneity within a hyperscaler infrastructure. So that's a type of simplification while managing this big, complex space. And again, from our point of view, a common platform is a way to bring together that big common building block, and then you can build best practices and the automation and telemetry around that, which is helping the customers move faster rather than being stuck in, sort of managing sprawling complexity.
Sure. I appreciate that answer. Anyone with a question here? I have a couple more. So we are here in Washington, D.C., so I would be remiss to ask something that's related to government, but some in our audience were curious, just from a Red Hat corporate level even, how do you view the Nist cyber framework in terms of developing your own cyber strategy, if that's something of importance, and I guess as well as following what things like the Office of Management and Budget are doing around Zero Trust?
2 awesome topics. So we're definitely very connected to the Nist framework. I'd say there's a number of different initiatives that are sort of converging. There's a connection between the cybersecurity work in Nist framework and then OpenSSF as a open source world looking at the software supply chain of open source software. So that is how we can identify the most critical components that we deliver out of open source, characterize the risk associated with those software components, and then manage the delivery of that software from the open source community through the ecosystem, which includes things like a software bill of materials, so that we start to know where our software is being deployed, and understanding threat models, which I think is a really interesting perspective, which is a little newer to not the security community, but the development community and certainly open source communities. So to me, there's a number of spaces that are of interest. We directly connect from a Nist point of view, and we're trying to bring in the perspective of the broader community to maintain that shared vision.
Great, that's great to know. And then I think one other topic that kind of stood out to our virtual audience, we're talking a lot about artificial intelligence, and you had mentioned that marrying data and AI without data scientists is something that is possible and something that you're looking at Red Hat. I'm just curious what other sort of workforce requirements would come into play there, and as well as IT requirements, and talking about that.
Well, there's an IT infrastructure that supports any data science activity. And that's where we've tried to bring this commonality to let the IT operations teams build a platform that can support both application delivery as well as data science as an activity. Data scientists are really rare and expensive assets in a company. And part of our focus is enabling data scientists to really focus on the data science and not the tool chain development or maintenance. And in that context, one, share and collaborate with each other across a common platform, so maybe have shared models and even influence each other in how you do model development. But also, there's data science as a discipline is a highly skilled discipline. Taking a model and integrating that into an application is something that we can do with application developers. So it's not necessarily making application developers data scientists, but bringing those 2 disciplines together in a way that leverages the skills of each and doesn't, sort of distract one skill set and focusing on the wrong discipline, if you will. So that's really how we're trying to focus on commonality, letting the IT teams build the same build common infrastructure, and then create collaboration across data scientists and application developers so that we can work together and build against those business outcomes, which I think are missing in many of the data science experiments, which is often why they fail.
Okay. I just want to again thank Chris Wright for that great presentation. We certainly appreciate it. And you did a great job setting the stage around cloud and what we need to be thinking about, and got us off to a great start today. So thank you.
Thank you.